enzymes and all sorts of things, because you can demonstrate biological action outside of the living cell. So there's nothing unique about the chemistry going on inside a cell. It's just ordinary stuff. So the kinds of things that chemists worry about, reactivity, thermodynamics, and so on, apply equally to things happening inside the cell. We apply lots of biological principles too about how energy is transduced from one form to the other, information storage and transfer by molecular means. All these chemical and biological principles are blended together in biochemistry. And when people started investigating the inner workings of what's going on in the cell, some basic ideas came to the fore right away. That is, there are big molecules in there made out of monomers. That was one thing that's very clear. People discovered that these big molecules have special conformations, or folded in special ways, held together by both traditional covalent bonds and weak bonds. We're going to spend a lecture looking at weak bonds shortly. And that the structure, the overall three-dimensional shape of a macromolecule is key to understanding how it works. Another principle that came to mind right away as people studied integrated metabolism is that any biological action that happens, like a hormone arriving at a liver cell, let's say insulin or glucagon arriving at a liver cell, having an impact on that kind of interaction comes from reversible binding events. So maybe hydrogen bonding or some other non-covalent force allows some stickiness to happen. So this hormone binds to a receptor, triggers some biological event inside the cell, but this interaction there, highly specific but non-permanent through the so-called weak interactions. And everything in biology, the so-called molecular recognition events, where a receptor recognizes a specific hormone, that handshake is done through non-covalent weak bonds, which is critical. You don't want an insulin cell to activate a liver cell permanently by sticking in there with a covalent bond. So we need weak interactions for lots of reasons. Also,